Yo, what's up, everybody? Welcome back. Today, we are working on writing a GPU driver for a virtual GPU that we have not implemented yet. So, context for this project is one day I think it would be fun to make a GPU, right? At some point, I bought this like roll of LEDs and I never did anything with them, but I thought it'd be kind of fun to like take like the shittiest microcontroller in the world that you can find, little like STM32 or something, like a $2 computer, and like drive this like wall of LEDs. So I could put like the LEDs kind of like on the wall like this and have like what is essentially a like really big low res screen, right? And if I wanted to do something like kind of like fun on this thing, we would have to like say I want to like do like some like 3D rendering on this for whatever reason. Maybe I want to play like Doom on it or something. Maybe Doom's a bad example. Maybe I want to play Quake on this thing, right? This $2 microcontroller, not good enough, right? And so what I thought would be fun is instead of doing something sane, what if we connected each of these LEDs individually to like one GPU, right? And we did like the hardware acceleration on this thing, and then we could like just issue like really the CPU on this thing could be like pretty nothing, and we could just do all of like the real work on the GPU to drive this wall of things with 3D rendering. It'd be kind of fun. But in order to do that, we need to come up with like what is a sane GPU design, and we don't know what that is. We don't know what a sane GPU design is. We just like write like OpenGL apps like kind of poorly sometimes, right? So we're on this quest to discover how do people implement GPUs, and I figure a step in that process is going to be how if we wanted to implement 3D rendering, say we like cut out the part of actually making the GPU hardware. What if we just saw how could we do anything, right? So my thought here is we will kind of work in a virtual machine, right? So you can kind of imagine you have like your host machine, host, and guest, right? And these things are kind of bridged by like QEMU, the virtual machine we're running. And the thought here is that like we will implement some sort of like PCI device in here that will kind of like take some instructions from the guest. So the guest is going to be running like Linux kernel. He's going to like talk to QEMU as if QEMU is like a PCI device. And then QEMU is going to like forward those like whatever we say to our GPU to some like picture somewhere, right? We can draw a little smiley face in here, right? So that's kind of like the plan. I think the immediate goal would be to just like spit out a picture of this thing. And I want to try to use like the Linux GPU driver subsystem to try to get everything to work correctly. We've kind of recently we worked on this test app. Let's see if we can bring it up. So here is like a virtual machine, right? And we worked on this test app, and he can draw to. Sorry, I need to get this thing in the right state. He should be able to draw a smiley face to the existing virtual GPU, right? And so what I'm hoping is that we can kind of like do the same thing, follow the exact same set of commands, and just draw to our own implementation of this thing, right? Because the idea is we'll start with like 2D acceleration, or sorry, no acceleration, just 2D only. So the way this thing works right now is he kind of allocates a frame buffer on the GPU, or I guess he allocates a frame buffer in guest memory, and asks the GPU on the other side to draw that thing. We're going to try to follow that for now. And then in the future, then we can start tacking on our own 3D acceleration calls on top of that. But the first step is just get anything drawn anywhere. And so we have this sample app that kind of does the minimal required work to do that. So he kind of uses this like dev DRI handle that shows up in Linux dev area. We ask him to like, hey, what like resources do you have? Can you like get us a connector like for like a monitor? And then can we like set this thing up and draw to it through this like frame buffer? And so the goal for today is for us to kind of mirror that set of commands so that this same app will work on our GPU. That's kind of the plan. For context, this is kind of the expectations of the like userspace API. So all GPUs, effectively, most GPUs supply this like kernel mode setting API for what is like basically before you get into like a real 3D context, you might still want to display some stuff, right? So like the Linux kernel is going to want to print characters onto the screen during boot up to say like here's what we're drawing right now, and like maybe if you want like a pretty boot splash, you might want some sort of generic way to draw like just pixels to the screen without having to worry about like real like individual pieces of hardware. So there's this thing called kernel mode setting, and this is kind of like the pipeline for all GPUs should support this. And so it kind of ends up over here with like, you know, a VGA connector, right? Which isn't necessarily a VGA connector, but like a connector, right? You can kind of imagine you have like your monitor, right? Well, we're going to draw CRT because this is designed around the CRT, which is kind of funny, right? And he's got like some analog cable going into some like PCI card or something, right? You're like a little GPU. This GPU is going to like talk to your CPU over here. CPU, right? So like one of the things that the CPU is going to do is he's going to ask him, could you draw this picture, right? But to draw that picture, to draw that onto the monitor, you're going to have like a gun in the CRT that's basically like shooting across really fast, going back and back, back and forth, back and forth, back and forth, back and forth, right? And so what you have to do is you have to say, okay, here's a picture, but there's like a chip on this thing that's going to like take the picture and like iterate the pixel by pixel and like put the pixel as like a voltage on this cable at like a specific time, right? So that's the concept of like an encoder, as well as this concept of like CRTC. This is like cathode ray tube controller. So like imagine that your buffer that you're trying to render is like 800 by 600 or something, right? But your monitor for whatever reason is like 320 by 240. So I believe that this guy's role is to basically say like, how am I going to scale this? Like, let me set encoder params to walk like 2 pixels at a time or something like that, right? That's like a thing that he could do. Then there's like basically this stuff over here, which is like, let me allocate an area for me to like write into to draw some pixels. Let me attach that to the concept of a frame buffer, i.e. something that the GPU can know how to draw. And then let me attach that to a plane, because like if you have things, you might have like a YUV buffer where you have like luminance and color kind of split up into 2 buffers. These might be represented as different planes, like as in like 2 physical different segments of memory that like together form one reasonable image. So that's kind of like this like plane thing is. And the reason we have to go over this is because all of these components are like exposed to user space, and so we are going to have to implement all of these things. So the basic plan is just to try to like walk this program start to end and try to write a driver that will talk to our virtual PCI device to try to do something sane. That's about the extent of it. I don't really know what that's going to look like. I've seen that there's this. I know that we have to like register our driver with the DRM subsystem, and I know that we have a way to like. There's this get version call, which is like the minimal, like the first. It's like your like hello world for your GPU, right? Like can I extract anything that like represents me from this thing? And then we're just going to try walking this thing front to back. So like, let's try to like get connectors and like try to allocate a buffer and like try to DMA that over to our host machine, stuff like that. But we probably will not finish this today, but we should try to start. So that's the context. And let's just fucking run it. Let's run it. So step 1 is we already have a PCI driver from our experiments the other day. So we have this Sphero LED driver that acts as a PCI device driver. So if I go into here, I go sys class LEDs, I see like a Sphero blue thing here, right? And like what I can do is I can go into Sphero blue, CD sys class LEDs Sphero blue, and I can like echo 255 into the brightness here. And what that actually does is that gets mirrored somewhere into like an SVG. I actually don't know where that goes. What did we do here? We have SVG, wrong folder, hold on. Test.svg, here. So here, if we open this SVG with GIMP, fuck, that's not what I wanted. It's not what I want at all. But we see like a little blue LED here, right? So that's kind of like our starting point, where we have like a way of communicating between host and guest through PCI, and we have a driver that's hooked up to that. We just have to now modify our driver to work with a different subsystem. So I think step one of this is probably going to be to take our existing LED driver and move it into the DRM subsystem. I think that's probably what makes sense. So where in here, in this like list of files, is like our reference driver, vert.io GPU. This lives in drivers GPU DRM. So I guess we'll kind of like shove our stuff in here somewhere. That is where we should go. Here we go. So we'll copy this into DRM. I already forgot, GPU, DRM, yeah. And we can maybe just kind of like put our thing in here. And we'll name this DRM. Well, everyone else kind of has their own folder. Everyone else kind of has their own folder, so maybe we'll do that. Let's do that. What do we call it? Hello? Oh, I named it wrong. Okay, let's put this in here. And let's kind of look for an example here. So they have like a kconfig and a makefile. So I guess we'll just kind of like copy these and kind of put them over here somewhere. And in our kconfig, we're going to say drm Sphero is our configuration. And we'll call this a Sphero GPU driver. And he depends on vert.io menu, and he probably depends on memory management unit. I don't think he depends on vert.io at all. We're not going to use the vert.io subsystem. But we will depend on the MMU so that we have some way of like mapping memory. Okay, so we probably are going to need KMS helpers. We probably don't need vert.io. And we probably are going to use this like shared memory backed buffer allocation stuff. So I think that's fine. The rest of the stuff we will not need though. And then we're going to enable mode setting automatically. We're not going to give anybody an option to turn that shit off. Then on our side, we're going to be like, okay, we have a Sphero GPU, is DRM Sphero. What was it called before? Was it called vert.io GPU? It was. So I guess we call this Sphero GPU, I think, because we have a Sphero LEDs. So Sphero GPU makes sense here. And he's going to come from Sphero GPU.o. And we're going to say kind of just start there. We're going to start there. Except you can't use the same name here. We've been bit by this before. So we're going to call it Sphero DRV and then use Sphero GPU here. And I think that's how this works. I think. We need config DRM Sphero GPU here. Okay. Okay. And then this now becomes a Sphero derv.c. Cool. Cool. So let's go into our like build. Let's go into our build and just try to readjust our build config to build the Sphero GPU driver, but not the LEDs one. So we've fucked something up because it's not showing up. We fucked something up, and I suspect that in the DRM kconfig, I suspect that this needs to like import something. So can we look for like vert.io? Aha, yes. So here we just want to source this thing. All right, let's try again. Let's try again. And let's look at, what am I looking for? Sphero. Cool, so now we have this Sphero GPU driver, and we can enable that. And let's turn off the LED driver because they're going to be looking for the same device. I don't really want to make a new PCI device. I kind of just want to use the same one. So we'll just turn this one off. And if we make J9, I think what should happen is that this thing should show up. I think that like basically nothing should change. So we should see we should see ourselves build our GPU driver, which I don't know if we see that anywhere, to be honest. Sphero? Yeah, I don't see that anywhere, which is a little concerning. But maybe it doesn't get printed. And I think if we run this thing, we should see it bound to that driver. So we should probably still see like the LED subsystem set up correctly because we didn't modify any of the code in there. but we should just see it come from a different location. So what's like, maybe we should modify that file a little bit. I think that probably makes sense. So can we kind of change this so that this guy has Sphero2 or something, right? Just so that we have some sort of indication somewhere that we have changed this file and it's getting applied. I think probably I want another environment open to run the build, so I don't have to keep changing directories. That would be nice. That'd be nice. So we'll give him a sec. Give him a sec. And we'll go to build Linux. And we'll just build again. We will build again. We'll just hope for the best. Okay. So let's run this thing. He's mad because probably we're already running and he doesn't like being run twice. There we go. And let's look here and see if we have sys class LEDs. We do not have our thing. So we've done something wrong. We have done something wrong. Probably we have to include our make file in the build as well. That would be my guess. So in the same way that we had to include kconfig, we probably need like vert IO. So in the same way we did this, we want like Sphero. That makes sense to me? Oops. That makes sense to me. There we go. Okay, so now we actually see our thing get built, which is a great sign. Great sign. And we can wait for it to finish and relaunch our virtual machine. Give him a sec. He's got some work to do. Who knows what he's doing? I don't. He's like, you know, linking the kernel, zipping them up and shit. Okay. So we see our thing back, and if we look at this, can we do like, maybe we look at like device, and can we like, how do we see a Sphero2 here in like really, really dark blue that's impossible to read, but this does say Sphero2, which is a good indication that like what we've done is applying. Okay, so we have our driver set up. And so the way this thing works is we basically say, hey, here is like a PCI device to look for. We look for like an AAA, and we have like made a virtual device that has the same vendor and device ID in QEMU. And so we like look for this thing, and if we find it, we know that we can like initialize this thing. So the PCI subsystem will basically say, well, we have this ID table. We initialize this thing at like compile time. We kind of put this driver somewhere. I think that this gets like put as some function that gets like in an init section somewhere. I don't know. It somehow manages to like set himself up so that when the kernel starts, it knows to like check this structure for if a PCI thing matches, and in the PCI subsystem, if he finds that thing, he will call our probe function. So at this point, we have like a PCI device that's like kind of set up, and I don't really remember what we did before. It looks like we kind of enabled the PCI device as well as requested regions. So I think that this allows us to like map. I think the way that PCI works, if I remember correctly, is that you can kind of like, you have these like regions of area of like addresses to write to, which can be like extracted through this like bar mapping, I think it's called. So your like PCI device, I think it's like PCI connects to like, I think it's like CPUs over here somewhere, and he connects to like a memory controller, memory management unit, and these same lines maybe here go to like this like IO subsystem, and I think both of these connect to the PCI card. And I think that like when you first connect, you talk through these like IO pins, and you just say like, I'm going to write to this address, and if there's a PCI card there, there's like reserved addresses for PCI cards. So you can say like, hey, give me some information about you. And one of like the generic things PCI cards will have is this concept of like bar, which is like, I think something address region, and they'll have like a few of these. And so what we do is, I guess this is kind of I think that like there's hard-coded addresses somewhere, like or the BIOS maybe populates this. I think the BIOS populates it. So I think the BIOS is like, hey, PCI, where do you want these like addresses mapped to? And if he will like configure the memory management unit so that when we write to certain addresses, they'll get like forwarded to the PCI device, essentially. I think that's kind of all hand wavy and could be wrong. But I think it's something along those lines. That's like my mental model, at least, which is good enough to do what we're doing today. And so that's kind of what's happening here is we say like, hey, can we like talk to this section of the PCI card? And then once you have like a section of the PCI card you can write to, you can kind of do whatever you want. And so I think that for now, we're going to kind of like delete all of this LED shit, right? Because we're not doing LED stuff anymore. Now we want to kind of hook ourselves up to the DRM subsystem. And I don't really know what that looks like. I've been kind of using this VirtIO GPU as a reference because, you know, this is what we have right now. This is like what we are using at this exact moment in time. And it looks like he has like a DRM driver that he sets up. And it looks like, I don't really know. I would assume that on probe I assume that like the VirtIO bus is going to like walk items in a similar way to the PCI bus, right? So this guy has like device IDs for VirtIO, and then eventually he'll be called with the VirtIO device. And I'm assuming that in here somewhere he calls, let me register myself with like the graphics subsystem. I'm assuming that he somehow like maps this driver in somewhere, which it does seem like he does, right? He says, let me allocate this driver with our driver parameters. So let's kind of just run it that way. Let's look at drm dev alloc, and I wonder like what like the minimal amount of shit that we can implement on this is, right? Let's just try calling drm dev alloc on this thing. And maybe that's it. So what does he pass in here? He passes in a parent device. So who are we related to? Okay. So let's go back into our driver. And we should probably be able to kind of take like a minimal version of a DRM driver. Let's just kind of like delete everything. Right? We'll start with the dumbest thing that we can do, and then we'll like work our way up from there. We clearly need some sort of like DRM subsystem includes, so without really thinking, let's just kind of do this. I guess maybe we start with only DRM, we kind of see where that goes. We have some like, our previous driver structure is no longer relevant, and neither are these LED specific things here. None of this is relevant anymore. Okay, so we are going to try, I guess, so where does driver mode set come from? That's clearly missing. So this comes from derv drm.h. Oopsies, wrong. I tried to do a tmux move, not a vim move. Okay, so this is now, these things look like they're resolving. I don't really know what these are. I think we probably want mode setting. I think we are going to support GEM, which is like a kind of like generic hardware GPU buffer management system, I think. We are going to say we want to render, and that I don't know what atomic is, but I think we probably just keep all of these here. I also don't know what sync obj is. So supports DRM sync obj for explicit synchronization of command submission. Seems reasonable. And cursor supports a cursor plane. I don't think we need this. We'll leave it on though, just in case. Just in case. So let's just try registering this thing and seeing like how fucking mad he gets. Right? So whoever registered this before, he was calling dev drm alloc. Okay. And I guess this is going to return us a DRM device. Pointer. And he wants to know who he is owned by. So we're going to look at our pdev, and our PCI dev is probably going to have a device in him. Like a struct device. Here we go. Struct device dev. Nice. And then I don't fully understand why we pass in parent here. Like, I guess because our parent is the same as this guy's parent. I guess we are not the parent of this. We are this. And so we're passing in our parent as his parent. Seems reasonable to me. And then I'm assuming that if we are going, like, this must be forward declared up here. Okay, so we'll kind of copy that. Okay. Which kind of makes it look like this is going to work now. Okay. So what else do they do? What else do they do? They allocate the device with some function pointers that they support, right? And then they then register. So what does register do? Register the DRM device with the system. Okay, so at this point, we don't really have a device. Or sorry, we have an allocated thing that we could work with. But the Linux kernel doesn't know about him. So we have to do this. Right? And presumably if we fail, like if we fail after this, we need to like free the thing we made. So we'll go to like error DRM, I guess, and we'll make an error DRM thing here. And this will just call DRM dev free. Surely they have to remove that thing somehow. Dev DRM put. DRM dev put here. So we free the thing that we made. Okay. Okay, and if we are lucky, this is maybe all we have to do. Surely not, though, right? But maybe. So I'm interested to see like what type of behavior we get here. And maybe we should be, if we, what do I want to see here? Okay, first of all, he just doesn't work. Oh, because he's mad. He actually cares about like unused variables and shit. Okay. So we'll just kind of comment out that stuff for now. We're going to bring it back because eventually we're going to have to talk to the BCI device. But for now, we just get that shit out of the way. And then we see what happens. It would probably be better if we had some faster recompilation mechanism here, but you know, we're at where we're at. Okay, so we immediately crash. That's kind of fun. And so it looks like he's calling register, and then on register he calls DRM mode config validate. Okay, and then immediately he page faults. So probably somebody is trying to access some memory that is not available, right? We're probably just violating the expectations of this guy. And what would be cool is if we could actually get like GDB here, which I think is doable. I think in our here we type -s, if I remember correctly, for like enable a debug server and don't run, like stop as soon as you fucking can. Then I think that we can call GDB on VM Linux. Let's get GDB up and running. So GDB VM Linux. And then we say like target localhost something. 5555? No. QEMU GDB server. So what happens here is like the QEMU like hosts a localhost target remote localhost. He hosts a like server that kind of implements like the GDB API. And so since the virtual machine knows like where the kernel is loaded and what address he's currently executing, we kind of have everything we need for GDB to work if we have our symbol. So if we hit continue here, we should see kind of the same thing here. And I think that we need to set a breakpoint somewhere. I think we want to set a breakpoint on die, right? So maybe we are going to create a little GDB script that does everything we need. So he's going to load VM Linux. He's going to connect to the connect to the QEMU. He's going to break on die, and then he's going to run or continue. I believe those are the steps. So we can do gb-x run.gdb. And it looks like he's mad. Cannot access memory at this address. Oh, so it looks like we can't put a breakpoint there. That's unfortunate. That's unfortunate. That would have been very useful. I guess maybe if we just backtrace though at that point, maybe it's fine. What are you debugging, Linux kernel? Yeah. So let's try just this. Let's try that. So here, eventually, he is going to get into this kernel panic. And if I backtrace here, he's also not very happy. Fuck. I thought this would work. That's unfortunate. I've had success here before. But I think that maybe we had to do a little bit more, and I can't remember what it was. So for now, let's try to maybe just use a little bit of our brains. So what does this thing say? He says that we are in DRM mode config validate, and he's got a page fault. Okay. So we could just maybe look through this and try to figure out. So presumably, so he's going to look at our device. And he's looking through our driver features. Okay. Cool. And somewhere he's looking for... Doesn't really tell us, huh? Doesn't really tell us. So, but I mean, CRTC, so he's going through each CRTC and each encoder, which we presumably haven't set up, presumably. So like, what is this macro doing? For each encoder, we are going into this mode config, which sure, dev mode config encoder list. Okay. So this is implemented here. And this has encoder list, presumably, which has a list head, which we definitely didn't initialize, right? So there's likely a problem here, likely. And I remember, I think I've seen that basically like on initialization, you are supposed to set up like what modes, as in like resolution and like resolution, monitor, refresh rate, like which port you're plugged into. Like that's like a thing that you can set up on initialization. So I suspect that this is where it's happening. So we're gonna like put a little print K in here that says before encoder iter and after. And while we're here, let's maybe try to implement this thing, because I suspect that we need to. Because we said that we have it, right? So he's looking for if we have mode set here. He's trying to say if we don't have the mode set feature, then fuck off, right? But we do have the we have said that we have the mode set feature, because that's like the thing that we're trying to implement. So, right, because we said that here. Hey, we have mode set. And so I guess the trick here is to look at vert.io GPU and try to see what they do here. So it must be on probe. And it must be before they register the driver, right? Because we know that we're crashing in here. So looking into GPU init seems promising. And what we're looking for, I guess, is the mode config initialization, right? So we can kind of, actually, maybe what's an easier thing to do here is we could look for who touches this thing. So we could look for vert.io GPU. No. Not really looking like where this comes from. right? I don't see anything vert.io specific in here. So maybe we'll go back to looking through vert.io GPU directly. So we suspect something on initialization, and we're just going to look for anything that looks like mode set encoder setup, mode set init, right? So this is probably what we're looking for. And here, he sets mode config, and he has mode config funcs. Okay. So I don't know if that's what we want. He also has DRM mode config init, which sounds extremely promising, right? So this looked like what we were looking for, right? Where he's accessing this encoder list that hasn't been initialized. This looks a lot like this. So let's start by just kind of copy pasting this out. We're not going to actually set up anything, right? We just want to see, let's call the common code at the very least. So sphero derv. Let's kind of like slap this here. And this is going to come from, I assume, the DRM device. So this takes a struct DRM device, which is DRM dev here. And I guess we'll kind of have the same problem here. If we fail, we still have to free our driver, but that's kind of it. Okay, cool. Let's see what happens. Oh no, see? Yeah, oh no. Well, we're in the kernel, so we don't really have a choice. Well, we kind of have a choice, but I'm not going to try to hook up to such like a big driver system with Zig. We had enough trouble when we were doing dev regex in Zig, and that was like hooking up to like almost nothing. So we are going to be in the C world for a little bit. Okay. Let's not run under GDB because that was a failure. So we'll just kind of delete this -s. AV Shadow, thanks for the prime, much appreciated. And we should see, okay. So let's see if we see our logs that we put in. So we added that before and after. Before encoder iter. And then we don't make it to after encoder iter. So it's a good sign that we were kind of on like the right track, right? But we are not quite there yet. So can we go back and see? Before, where were we? It was like config validate. So we are in DRM for each encoder, which looks at each element in the encoder list and calls fix up on that thing. So can we, how does this list for each entry macro work? This is a for loop. So this is just like a glorified for, which means we can do this. We can say looking at encoder. Do we need new lines here? I think we actually do. I think that causes some flushes, so maybe we should be a little careful here. And then can we get some information out of this encoder? We can look at his name. We can look at his name. Right? My fucking muscle memory is telling me to type Zig build, which I shouldn't. I should type make in another terminal. Unit the config after the called register. Did I? That's pretty fucking stupid if I did. I definitely did. Thank you. You are correct. Good eye. Good eye. So we really kind of just accomplished nothing there, but, you know, we'll get there. Does Zig not have something like bind gen or autosig? It's like in the kernel, it's like, so it does have, like, you can import C bindings to stuff, and it does a pretty good job there. But it doesn't have support for bit fields, which are used in pretty much every single kernel device, because they're kind of in like the root K object, and so those things you can't like instantiate them, and then it gets kind of like hairy from there. Okay, we booted. Okay, so we do have 2 video cards. I don't know if this is more than the amount of video cards we had before. So can we do these like go anywhere? Do these go anywhere? So I guess we want to look at our PCI device, or maybe we can go to like sys class DRM. And do these kind of go anywhere interesting? PCI device 40040, which ls PCI-V, we're at device 5. So it looks like we have not done whatever we have to do to get these cards to show up somewhere. But we are not crashing, which is a pretty good sign for us. Pretty good sign. And maybe we should also indicate here successfully registered with DRM. I suspect that this is happening because we would see, I don't see like errors anywhere here. And so it's probably, it'd be interesting to see who creates those dev DRI handles, right? So maybe it's like skipping everything interesting. So initialize this. Initialize blank, 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 blank. So can we look for those lines? Does this have search in it? Probably not, huh? But I think that we print something. We print yo yo yo. So I think we call like dmessage into less maybe, and search for yo yo yo. Okay, so this did initialize. Oh, okay, wait. Initialized null 000 for PCI O on miner 1. PCI 00000. Okay. So one of these guys. Oh, both of these are PCI 0000. So initialize vert.io GPU. So this, he's like, we do have 2 DRM initializations, but this one seems a lot more reasonable than ours. So let's maybe try to populate whatever needs to get populated for this to work correctly, right? Because they're saying vert.io GPU, they have a version, and most importantly, they have like a full PCI device ID, right? So I'd be curious to know how they get that working. Which means that we look at this register call, and in here, he has dev primary index. Oh, hold on. So the last piece is for blank on miner. So we're looking for dev name dev. Dev name dev. Where device structure of the bus device. Okay, so do they assign that anywhere in like the vert.io version? Do they? How do I make this big? Here we go. Dev. So this is the interesting piece here, this device here. And maybe they do it in here. One sec. Yeah, dev private. Can we look at like maybe who assigns that thing? This does not look very useful. Get device parent maybe. DRM dev init, so get device from the parent. Who? Okay. Interesting. My gut says, based off what I'm seeing, that this doesn't make sense here. That's just kind of what my gut is saying, without really much of a good reason for it. I'd like to see what happens if I do this. Ooh, passing strict device. Maybe not. What does he expect? He expects a parent. So can I do like this? I want to know what that does. Maybe it's wrong, maybe it's not, but I just want to know. I'm expecting to see because it looked like we were getting like the PCI bus there as the driver name instead of the PCI device, and I expect the PCI device. So it could be that like the vert.io scheme is just maybe a little bit different, and so maybe that's why they pass parent there. Let's see. Let's see. We can always try stuff, and if it doesn't work, then we know it doesn't work. But here we are looking for. This makes a lot more sense, right? So this matches a lot better. Here they said initialize vert.io GPU on number 4, minor 0. And here they have us on number 5, minor 1. And this matches up a lot better with our expectations, right? Because we are number 5. This is us. So I would guess now, if we go to sys class DRM and we ls-l, we now see that card 1 maps to our driver, which is very cool, or at least our PCI device. So what would be interesting now maybe is to try to extract some information about our driver, right? Ideally, we should get the name in there, and we should be able to extract that name from userspace. So let's try to do that somehow. So I saw that there's this call. If we go to like the DRM ioctls, there's this thing get version maybe? Version? Here. This thing is an ioctl we can call who fills in this DRM version thing with the name of the driver as well as some other information, right? So I expect that this is going to come from the same thing that's printed in that initialization message. Right? So they are copying version name from dev driver name, right? So I presume that if we fill this thing in, that we'll be chilling, right? So let's look at the vert.io example again. This is the version of the code that we know works, and I assume that they have a .name in here, fills in with driver name. Where is driver name defined? This is just defined up at the top. Right? So we should probably be able to do the same thing here. We should be able to do the same thing. So if we just take here, we go like name is equal to Pharaoh GPU. I expect 2 things to happen here. 1, that initialization message shows our GPU. And 2, that we can query that thing from user space. Those are my 2 expectations, and let's see if that makes sense. Which means that we're going to have to write something that tries to query it from user space, but we'll get there in a second. We will get there in a second. Compiling. It's a hard life out here. All right. View, serial. And we are looking for initialize vert.io, initialize Pharaoh GPU, big win for us, okay? And now let's try to query this thing. Let's try to query it. So, I think what makes sense here is probably to get into our test app setup here. And I think that we can just kind of in here, try to open card 1. We'll just like if true return here. And can we call like DRM, am I in the right environment here? I think I'm not. Hold on. Let's get in the right environment. And we just want to call get version and see what happens. That's all we want to do. Give it a sec. Okay, where am I going? Test app. So all we want to do is we want to call something along the line. So the typical pattern for these GPU drivers, as far as I can tell, is that like you don't call the ioctls on them directly. Where ioctl, for depending on the context of people who are in here, your driver is kind of exposed as this like character device in dev DRI, right? So this is just kind of like a file that you try to open, and your files typically you can like read and write to them, right? But sometimes for these drivers, you might have like this like out of band thing that you want to do, right? So you might want to like trigger some event on it. And so there's like APIs that you support that file support. You know, there's read, there's write, and there's this other one that's called ioctl, which stands for like IO control, I think. And so this is kind of how we like talk to our driver. Now these ioctls, typically you would like call them yourself. However, I believe from what I've read in like the Linux kernel driver stuff, which I'm wrong a lot here, right? Because I don't know what's going on. But it seems like libdrm is like tied very closely to this because in the driver guide it said something along the lines of, because GPUs are so complex, the user space API, it's impossible. Usually the kernel has this like very strong guarantee that if it worked this way before, then it'll work that way later. But with GPU drivers, there's such a large surface area of like stuff they can do that it's hard for them to know if somebody is depending on this behavior. Is it just like an accidental implementation detail, or is this like actually how the thing is supposed to behave? And so libdrm is like one of these things where it's like we're tied to libdrm because like that kind of like scopes the surface area of the API a little bit. As that's my understanding. Could be wrong. So typically I would call ioctls directly, but here I'm willing to go through DRM mode, probably at get version. No, maybe we'll look at the libdrm source code to try to figure out where they call this thing, because presumably it's in there. It might not be. I could be wrong, but I assume that it's in there. So we have it checked out somewhere. Libdrm. And just can we look for like get version? Looks like it's not in here. Unless it's not called get version. I already forgot. DRM version comes from ioctl. It's not called get version. It's just called version. My bad. And it looks like this is wrapped. So it's just called DRM get version in here. And we are going to use our thing. We're going to say error get version if this thing fails, and we'll get a version of it. DRM version. Cool. And this will then from here we can just try to print what we got. So we'll say driver name, and this comes from version name from 0 to version name. Boom. Simple. He doesn't like this though, because this thing has to be intcast, because Zig only supports indexing by usizes, and ints are not usizes. And then I think we have like this scp command somewhere in our history that we can use to like just kind of run this shit. So we need to first start our virtual machine. That is true. We don't have run.sh in this directory. That is also true. Okay. And if we want to copy stuff into this, we have to have network up and running. So we need to run our DHCP server on interface enp03. I don't really know how this works. I think QEMU must have a DHCP server built in, and so like the network card that it injects like knows that it can talk to QEMU, and QEMU can like give it an address, I guess. I don't really know though. And then we should be able to go SCP that shit in. And we do see driver name vert IO GPUs. That's really good. And if we change this to look at card 1, which we believe is our card, we should see it say card, we should see Sphero GPU instead. But instead he says no device. That's interesting. Because lsdev DRI card 1 does in fact exist. However, we are getting error no device in our thing. So where does that come from? Probably this open file, right? Probably open file. One of the things that it can return is enodev, would be my guess. So this refers to a device special file, and no corresponding device exists. This is a Linux kernel bug. Okay, so my suspicion here is that we have to register some sort of callback for opening the driver. That's just kind of hand waving my guess, right? So we could look at vert IO GPU derv, and we could try to see if they have some sort of open thing registered. which looks a lot like this, right? So who knows what is going on here? What is going on here? He is allocating some, so he has like file specific information associated with him, right? So when somebody opens him, he allocates this thing, and then he does like some tracking of stuff. We don't have to do any tracking of anything right now because we don't do anything right now, right? So we can kind of handle that as it comes. I think for now, we probably just want to implement open. So I would be interested to see if there's some sort of default we can work with. Private file. I think it's a private data associated with this file, like driver specific, I think. That would be my guess, but what do I know? Okay, so let's implement open. So we have, something like this, and Sphero GPU open. Now I know that there's a lot of cases here where they kind of have like default implementations. So useful for setting up driver private data structures, blah blah blah. Since let's see, I guess, if there is some sort of common code that's supposed to be used, we could find that in the vert.io derv implementation of this thing. So do we see anything that looks like them calling into some DRM subsystem? And I think the answer is no. So I'm kind of surprised, honestly, that this has to be implemented. So here they do, if that thing exists, then we try to call it. But otherwise, it seems like it's like mostly fine. So that's a little surprising. A little bit surprising. It seems like that's the only place where it looks like this would be called from, according to our indexer, which, our indexer can lie, but according to our indexer, it's the only place it could be called from. So it looks like my guess here is actually that it's failing some other way. So it'd be interesting to maybe look for like no-dev in here. Like how... I wonder if we can like breakpoint here or something and like see where we came from. It would be nice if like maybe oh, we already tried breakpointing and that didn't work. Fuck. I mean, maybe the breakpoint, we were struggling on like setting breakpoints right on initialization. There's a chance that we could still set a breakpoint after initialization has happened. So I'd be interested to try that. I'd be interested in trying that because I think that GDB will be extremely helpful if we can get it working. So I'm willing to take one more run at it. One more. So let's turn on that -s because I know that we've seen it working in the past as well. Why do we have enable KVM in here twice? That seems wrong, but whatever. Okay, we'll run. And we will go back to the Linux build. Wherever the fuck I am, Linux. And he just does this, so gdb-x run. Okay. Then we are running, okay. And if I hit breakpoint here, can I break at DRM file alloc? No. Fuck. All right, well, it was worth a shot. Worth a shot. I know I'm gonna have to like do some off-screen work to try to get this working because I know I've got it working in the card, or I know that I've got it working before, and I think that we probably are just missing some kernel configs that we need or something. Where is the card info? I'm not quite sure what you're asking. Which card info? Okay, so DRM file alloc is who calls open. We should probably like look through this whole stack. Like, how do we get here? DRM open helper sounds promising, to be honest. DRM open comes from somewhere. So DRM open is this like I915 driver fops. Oh, I see. So this is not that helpful. This is an I915 specific implementation. GPU driver fops. Okay. This is interesting too. right? So file operations you can do on this thing. Maybe this is where it comes from. We should probably look at whoever creates the character driver. I would assume they like, do they use these things? GPU driver fops. So this is a file operations. This sounds likely to be it. So DRM file. It could be this. It could be this instead of this. Because in the file alloc, this eventually comes from client open, as well as open helper. But open helper is only called from this I915 specific file. Oh no, this is DRM file. This is not I915 specific. It was just when I found references on it, it was used here. Oh, okay, wait, hold on. So in the virt.io driver, fops, they eventually go into the DRM subsystem. I see. But kind of just by default here. So these are default file operations that are used in the case where you are a GEM driver. I don't know if we're a GEM driver yet. I really don't. I expect that we will be. It sounds like, from what I've been reading, that GEM is this like way of interacting with memory management that kind of like provides a bunch of extra useful utilities. So I suspect that this is where we're going to end up. So maybe it makes sense for us to do that. But for now, I wonder if we can just... I would like to try implementing this fops structure as well as this GPU driver open on our side. And then we can kind of just see where that goes. We can see where that goes. So we will go to Spherophoria GRV, and we will put a log in here, and we'll just say print k called Sphero GPU open. And I suspect that this is not where we're going to end up. Instead, I think we will end up in fops. And so we need to create this thing. So static struct fops, file operations, Sphero GPU fops. And now we just have to implement open on here, and we'll see which one is called. Sphero GPU. We'll call this like fopen or something. And we'll implement this as Sphero GPU fopen. And we'll just kind of see where this goes. See where it goes. See where it takes us. What file are trying to open this returning unknown device? Dev DRI card 1. Dev DRI card 1, which we know exists. It is what we think is the file handle to our GPU. And here, I guess we'll say print k, opening GPU with file ops. And here he's mad about these missing parameters. So can we like... he doesn't say what they are, fuck. So we're gonna have to, I guess we can just assume that it's inode and file. Okay. Let's see what happens here. Initializing, we need this to be a pointer, I guess. Okay. And let's run it. See what happens. We'll see what happens. Somehow got hit with 2 sets of 4 ads in a row. Dude, that's the worst. I'm sorry. Okay, let's run this thing. And let's see. So, test app. So, opening GPU with file operations. So, this is interesting. So, that matches up with my understanding here, that this GPU open is not being called yet. Not being called. And it looks like now we're failing at get version. So I'd be kind of just interested to like just follow the errors and see what happens. So I guess we don't really know how it's failing here right now. But we can probably look at DRM ioctl and we can try to see like what does it do when it calls get version, right? So he has an error if he has copy field fails. Okay, so there's a couple. Let me think for a second. There's like kind of two areas where this could fail. One is if this DRM version function is getting called and it is failing, right? Which could be true if we are kind of failing into this. Like this stuff is causing problems, right? Another option is that we have missed some sort of important initialization for these DRM ioctls to get registered at all, right? We haven't really like tracked down where this stuff gets used, right? We're kind of just assuming that the DRM subsystem automatically hooked this shit up for us, right? This DRM ioctl function. It looks like in this gem ops, he actually calls DRM ioctl here. So I'm actually kind of interested in doing this for ourselves. And I wonder what, like, maybe DRM open is also very, like, important. It might be, right? Like, what does he do in here? He might set up some state that is required for, like, the general DRM subsystem. So I'm kind of more, at this point, I kind of feel like we should try just doing open. We should probably try doing this. Now, the only thing in here that is gem related is the mmap function. So we can kind of just do the rest of them, right? Like, maybe. Macro to generate file operations for gem drivers. This macro auto generates a suitable struct file operations for gem-based drivers, which can be assigned to DRM driver fops. Note that this structure cannot be shared between drivers because it contains a reference to the current module using this module. Understood. We didn't do that. Note that the declaration is already marked static. If you need a non-static version of this, you're probably doing it wrong and will break this module reference by accident. I like that type of comment. You're just like, if you want to do that, you don't want to do that. Like, you fucking idiot. Okay, so I'm willing to take a hit and okay, I'm going to only assign DRM ioctl, and then I'm going to make a large assumption that this is going to crash something, right? Because almost certainly, right, this is using, oh, I mean, we don't even have to check, right? He's using DRM file private data. He is very much assuming that we have some private data that is initialized with DRM file, which we wouldn't have done. That probably gets initialized in DRM open, right? We can look for, what's it called again? Private data. DRM open helper, right? And this is called by DRM open, right? So we can probably make an assumption that we fucking need that shit, right? So let's, how do I want to do this? I don't really want to explicitly say that I'm a gem right now because I don't know what that means. So I think we probably do this. We probably just copy paste these functions into here. I'd also like to be clear. if you're watching this and you're like, this is a reasonable way to like do anything, let's just be very clear that I have no idea what the fuck is going on, right? So don't use this as a reference for how you should behave. And I assume DRM open must come from like DRM file.h or something. So we must need to include DRM open file here for this to work good. Now we are still missing DRM ioctl, so this must come from, oh, is there an autofix? Oh, that's kind of sick. Good shit, Clang. Good shit. All right, so now I think there's a non-zero chance. Oh, we also missed this module thing, right? How was that done? It was he called this, which has owner. We need owner as this module. Okay. I don't know what that means, but it must be important. Because we saw it called out in a doc. All right. We run it again. He's mad about something, actually, which is kind of fun. Sphero, oh, because that's no longer used. That's true. I have a question for you, but you can put in Discord. Yeah, I mean, sometimes I'm not really in super question answering mode right now, so you can try asking here, and I might answer, but also feel free to post in Discord if I don't answer here. Apologies. I feel like I'm, sometimes I'm just like locked in, or like don't want to like deviate because like my head cannot handle the extra shit. All right. Can we look at test app? Too off topic. All right, sure. If you believe that, then we're good. So I wonder what is happening here. So this is crashing when we run our app. We're getting a kernel crash here. And it's coming from DRM ioctl kernel from a copy field from PFX DRM version. So I suspect that we have some uninitialized memory in our driver related to version info. That's just kind of like my suspicion here. So we can look at the ioctl implementation of this, and we can look for DRM get version, DRM version, and well, DRM ioctl kernel. This is where he is right now. And it was DRM copy field, which must be getting inline somewhere. Yeah. Sure. So maybe the backtrace isn't quite correct or something, but it's one of these DRM copy fields, and it says PFX version, DRM version. I don't know how that's getting into the backtrace here. Really, that's a little, don't really know what that means. But we might want to look at these. So here he is trying to just copy this field 0 into the date. So it can't be this. It shouldn't be this. But our description seems unlikely to be set. Right? So he is probably just copying a null pointer in here. Or just like, yeah, null pointer. And depending on how DRM copy field works, if this thing is a null pointer, then we have a fucking problem, right? Although he does do a check for null, so I would expect this to not crash. Really? I'm a little surprised here. Oh, the value to copy was not set. Oh, sorry, this is buff is the upload. He's not checking value. Oh, yeah, okay, so we're just fucked. Yeah, okay. So we will set description. We will set description in our driver field. And hopefully that will do something for us. GPU Spherophoria's testing GPU. We'll just call it that. I was gonna try to put some clever message like LOL it's shit, but you know, clever, it's shit. It's not really that clever, but all right, let's just kind of see. Let's see what happens. Let's see what happens. I should make some notes here for things I want to do off screen. So off screen, we want to like fix GDB. This will be very important. And we also want to speed up build process. Both of these things are a little annoying right now and aren't something that I want to tackle right this second, but I do need to tackle them soon. Because the longer we leave it, the more of a problem it becomes. Okay, test app. Let's fucking go. Let's fucking go. That's our fucking driver, baby. That's our fucking driver. All right. So we have kind of like, that's kind of like the hello world of our driver kind of up and running, right? We have something that does something. And I guess the next steps here are to just try to continue on with our little test app and just, like try to keep going, right? Because presumably the next thing that we do is also going to crash, right? If we just like take this if true and like move it down a line, this if true return, I would assume that this will also crash. I would assume. So we need to go back in here and we need to do IP link udhcpc with this. We get an IP address and then we do zig build and copy that shit over and run it. And we actually do That actually doesn't crash. However, it gives us kind of nothing of value, right? So if we're like, hey, how many CRTCs do we have? It's like, oh, 0. How many frame buffers do we have? 0. How many connectors do we have? 0. How many encoders do we have? 0. So it's like, we can't really do anything with this. So probably what makes sense here is to just, we kind of like say this is a success, but this will not be, right? If we try to get our connector out of this thing, we're going to have a problem. So the next thing to do is going to implement connections. So connector is kind of like, if we go back to one of these pictures that we drew, connector is kind of representing like the detection that, like, if this is our GPU, that this port has something plugged in, right? You can kind of imagine, that like you have like some, you know, like an HDMI cable or something, right? Or something in here, right? And one of these pins, when you plug it in, basically like, maybe this thing is kind of like by default, he's kind of like how does this work? It's like pulled down to ground or something. So you have like this pin with like a resistor to ground or something. And then when you plug it in, you like bridge this thing to like 5 volts, right? Like you could, this, I don't really know how this is actually implemented, right? But you can imagine like you plug this thing in and like the cable you plug in like bridges these 2 wires. So when you read this thing out, if there's a cable plugged in, this is like big number. And if there's no cable plugged in, it's small number, right? That's kind of like a way you could implement this. And so you can imagine that you're like, you have some chip in here that's like monitoring this wire. And when this wire go up now, he goes, oh, thing plugged in, right? That's kind of what what we would want to implement here, right? Is like, when we say get first connected connector, we are iterating all of the ports that our GPU says he has, right? We have like 2 HDMI ports and like maybe a couple display ports. How do they look like? Like kind of like this, right? And we like kind of walk over them and just like check, does this encoder think that this thing is plugged in? And so I guess in order to implement that, we would need to have a concept of a connector on the other side. Now, we could hard code it for now as just we unconditionally have something plugged in. This is why computer engineering is greater than computer science. I mean, I just kind of made that up. I wouldn't trust what I just said at all. Right? But yeah, I guess we can just kind of model this thing as unconditionally we have something plugged in. That way I don't have to like implement some sort of communication with the other side yet. We can just kind of do it all in driver land. So let's do that. Let's try to indicate to ourselves that we have one thing. So when we were in the vert.io GPU thing, I think we saw some function that was like init mode setting or something in there here. I think it was in their init. They had mode set init here. And I think that this guy kind of set up everything that needed to be done, right? We can see that here he has mode config, max width, max height. These are fields that we were missing in ours for sure. And then he has functions that are called. Okay, so here he does not set the number of connectors, right? We don't really see that happening. But we could look at what's in this mode config, and presumably connectors are going to be in here. There's a connector list, num connectors, ID allocator for connectors, and then there's a list of them, which is like I assume this is like a linked list, is how this shit works. I don't really know what like the kernel, what kind of like kernel structures we have available to us, but I'm pretty sure these are linked lists usually. So presumably these functions are going to be interesting. This like mode functions. Frame buffer create. Nah, that doesn't really feel like what I want. We kind of want something that like it appends to the connector list. That's kind of what we're looking for. Right, so in here, well, that's a big assumption actually. Maybe we start on the iocta side. We have this thing that we know. We know we are calling mode get resources. This is our input. And so in here we can look for how does he determine how many connectors there are for each encoder for each connector. Okay, so this comes from con iter, which is specified by this. So we create a list iterator that looks at something. What the fuck does this make? Oh, I see. So he knows which connector he's pointing to, And when you iterate this thing, you call drm list next. And so he knows that he's this connector, and then he must be able to like derive where he is in the list based off of that somehow. So he goes like, oh, the connector has a list head. Weird. Okay, this is not, I feel like this is not how I would implement this, but that's okay. I'm not them, and maybe there's a good reason. Who knows? Maybe she's born with it. Okay, so but we're basically looking. We can assume. we shut the fuck up, okay? Figure out what words you're trying to say, Nick. We can assume that this is turning into count connectors, right? So the way he's counting the connectors is he's iterating this connector list, right? So how does he set the first element? Oh, it's initially set to null. And then when he calls next on this thing, he must check for null. No. Old con config. So if we don't have an old connection, we start with the connector list. Right, so we're looking for someone who assigns this. This is what we're looking for. So mode set helper. This is one way you could do it. Is intuition is great in many domains. It often doesn't have to match reality. You might say bullshit is a great heuristic. Yeah, I do find that like my general way of thinking is like I have a mental model of the world, and like that includes like my mental model of like other people, right? Like I have like a mental model of things, and that mental model will never be like correct, but it can be good enough to make good predictions. And every time your prediction is wrong, you just have to go back and update the model, right? And it's like I remember I had this guy that I worked with one time, and like I remember being so frustrated because like I could not come up with a mental model that made his actions seem sane. And then one day, like years and years in, I was like, oh, what if the model just has to be that he's going to say whatever he thinks you want to hear at that moment in time. And like all of a sudden, it makes like everything click, right? It's like, okay, that's like, that one was like a surprise to me because I didn't think that model existed. And now that's like a thing that I have in my repertoire to see like, is this person one of those people or is it one of these people? And it's like, you just kind of like keep updating the models. They never have to be perfect. I'm sure that that's not actually what they were thinking, but it made good predictions for a long time after that. And it's like, it's kind of fun to just like, make the LLM. Yeah, I do feel like you keep making incorrect approximations of things until you get close enough. Okay, what am I looking for? I'm looking for like whoever inserts into this list. Whoever inserts into this list. So mode set helper and mode config. This guy just initializes the head. Iterative feedback loop. Yeah. In technical situations, just knowing that it's possible to do, I don't know how they did it, is often good enough. Yeah, I agree. List add tail. This looks probably like what we're looking for. DRM connector init. This looks like probably where we're trying to go, huh? So someone calls drmm connector init and drm connector init. The fact that there's two of these functions, one with an extra m, is something that we should actually probably look at. That's actually kind of concerning. But we can kind of see where these come from. So qdev, vgdev output, vert.io, GPU. Yeah. Here we go. So on mode set init, they call output init, which calls connector init. Okay. GPU, mode set, output, connector. Don't let me forget. So I guess maybe if we just leave this window, oh fuck, as I say, we should leave this window open. I immediately close it. So was it in output, DRM, mode set init? It wasn't config in it. It was the connect output in it. Yeah. So in output init, they had connector in it, which inserted this thing into the list. Okay, so how do they do this in like our reference driver? He creates a virtual thing with some functions associated with this connector. Okay, so that's going to be interesting for sure. this connector is related to this output in some way. So in their version, they have vert.io GPU outputs, which I presume gets initialized when we talk to the other end, right? So I think that it looks like, kind of hand wavy, they call this vert.io GPU command get display info, right? And if we go into the QEMU code base, which I think we don't have an environment for right now, so one sec. Let's do this. One sec. Did the screen just shrink? I don't know. I don't think so. Maybe. So if we go to source QEMU, we can probably find this command in here somewhere. Get display info. Yeah. Yeah. So someone, like, basically what happens is they queue up this command. It does feel like something's wrong here, right? Where are my line numbers? I must have clicked something. So where were we in here? It was in probe. We called GPU init, which called mode set init somewhere. And then he called output init. Right. And then he called connector init based off of this output thing. Where were we? Someone was setting output connector probably. Yeah. Right. So here we see that he's kind of like right. So it was this callback. It was queued here. Right. So he creates this command get EDID, right, which is implemented over here. He has this like queue of stuff, right? I think I was looking at this the other day, and I believe the way like vert.io devices work is you have like, let me see if I can remember correctly. So vert.io can be implemented, not necessarily will be, but can be implemented through vert.io PCI. So there's like a PCI device here, and like we said before, the PCI device kind of has like access to like, he connects to like CPU through, I guess he doesn't connect to the CPU. He connects to the IO bus and like the memory controller, like MMU maybe, hand wavy. Then when we talk to this guy, because he can talk to the MMU, I believe what happens is that in the guest, like in Linux, he basically like allocates some contiguous section of physical memory, and he calls this a queue. And what he does is, because this guy can connect to the MMU, the PCI card can like look at this section of RAM directly, right? But what he doesn't know is like when something in here changes. So if I remember correctly, what happens is there's a bar in the PCI device, and one of the things that you can do is you can say notify. And when we were looking at like the implementation of vert.io PCI, basically what happens is you have like a pointer into this queue of like where you are, and you kind of like move this along and like put stuff in the queue, right? You just kind of like shove messages in here. Then you call this, like you write to this notify thing, and then the PCI device goes like, oh shit, there's stuff to look at. And because he has this stuff mapped directly in, because at some point we also had like a message in this bar to say like where is the queue, we can like write to some address in the bar to say here is some memory to look at. He knows where he's looking at, and then so that's what's happening here is he is creating a command to he writes that command into the queue and then waits for the response from that thing. So you say like virtq push, virtq notify, and then he like waits for the response somehow. That I don't really know how that's tied back, but I think that probably what happens is like either there's like a response queue, or like maybe the PCI just writes the response like directly into where the request was. Maybe, I don't really know. But so it looks like that's kind of what's happening here, is like here when we call get EDIDs, we allocate this command, we queue that thing, and eventually this callback will get called when that thing finishes. Yeah, and then that will set the connector information, right? We saw EDID connector update. I can't remember how we got here. It was somebody in the queue. Yeah, EDID connector update will populate this thing with the appropriate stuff. Now, for us, I think probably it makes sense to model the behavior of like we want to ask our PCI device for something. I think I'm okay with that conceptually, right? We could have hard-coded in the driver, but that means that if later we want to do something like have the if we want to like behave more like a GPU, that means in the future we'll have to like make this change that kind of visually is nothing. So I think it makes more sense to kind of start trying to do it correctly. So I think that what we want to do is we want to somehow query our PCI device for information about a connector. And I think that makes sense. So update connector information from EDID. That's like one thing we can do. Is there anywhere else? Like where is this thing like first assigned is the question. I don't know if this is like the first place or the only place, you know? So DRM connector to virt.io GPIO output. None of this looks like they're writing it. It really looks like this is where it gets written. So something I'm confused about though is when we call output init here, this thing exists already. So how does he exist off rip? He must have some sort of initialization that I'm missing. Oh, while we're here, also, I think the extra M, when we saw those functions that were DRM or DRM is that the extra M means that things will automatically get cleaned up when the structure is removed. Because I've seen like devm before as like kind of like scoped pointers that are associated with the device handle. I assume that this is the same thing here. I assume. So we're definitely missing a piece here though. We're missing a piece, which is how the fuck do the outputs get initialized for the first call? So he has num scanouts here. I guess we want to see how num scanouts get set. Num scanouts equals. So here he gets these things from somewhere. Get display info. So he calls virt.io cread le. So config space. I see. So they have two options here, I guess. One is that you can read directly from the memory of the PCI device, or in this case, virt.io device. But sometimes there will be updates that come in over the queue. So I guess if that is the case, we can specify. We can do whatever we want. Oh no, wait, here we go. So he only uses that to get the number of scanouts, but not the actual information. Aha. Yes. Okay, that makes sense. So here, then he sets display info pending and he submits things to the queue. Gotcha. So it kind of looks like PCI device. He kind of reads like one of the things that you can do on this is like num ports. He gets this. This says like he reads this and it says like 4, and then he goes into like the queue of stuff to do and he issues like a get display info for each of these. And then eventually, like, the PCI card will like be like, oh, we got to do this, got to do this, got to do this, and then he like populates that stuff and sends the answers back over. Now the question is that how I want to do this? Right? Eventually, we will probably have to set up command queue. Eventually, because like the way that like all like 3D acceleration works is like you submit stuff to the GPU to do asynchronously and then wait for it to answer. But in our case, I think I just want to read directly from the memory of the PCI device. That feels like the easiest way to do this for now. So I guess we're going to have to figure out what type of information that we want from this. So I think we go back over here and we look a little closer at this like get connector call, right? So he's going to call DRM mode get connector, which is going to be implemented somewhere. We can assume that that goes into the DRM ioctl. Connector in all caps, maybe. So that's going to end up in here. And I guess what we're going to try to figure out is what is like the output of this thing? What is the output of this thing? So he's going to look at which encoders, which modes, which properties. There's a lot of stuff in here. A lot of stuff in here. And most of this doesn't actually have anything to do with anything that we care about right now. Really, the only thing that we're looking for in our example is we're just trying to see if the connector is connected. That's the only thing we're looking for. Is that Rust? This is Zig on this side, and then this is C over here. So I guess if we are trying to figure out if a thing is connected, we could define a card that has one connector on it, and then we just ask if it's connected or not. That seems reasonable to me. That seems reasonable. I guess in the future, we'll probably kind of pretend it's always connected in reality. I don't know if we would ever actually do like connector detection, right? In the world where, you know, we set up this LED wall where everything is plugged into the GPU, like, will anything ever not be connected? Maybe not. But I still would like to try it. I would like to try it. So we are looking for whoever sets that connected flag. So we're looking for connector.connection equals connected. Connection. So this is what we're looking for. Who sets this thing? He comes from connector status. And presumably this is updated by some function. Jeez Louise. Probe helper. I guess maybe we look for who calls with this. DRM client mode set equals. Everything is like comparing. I want to see who like sets something. Either I'm looking for like a function call with this in there. Here we go. So this, what's going on here? This is called on connector functions. Haha, yes. So we register a connector with some functions, and our detect mechanism can just be to query the PCI device at like right now. I like that. Okay, I think we're starting to get a picture here. I think that we will be I'll be happy with our progress today if we get to the point where we can detect a connector that is plugged in. That's what I'm looking for here. Okay, so this is an output init. He calls connector init with the connector functions, right? So we eventually will have to have to fill these things out, but we'll call this Sphero GPU connector functions. And we're going to have to like Maybe use helper probe single connector modes. That seems probably fine. Atomic helper reset, nice. So a lot of these DRM helpers are great. The only thing that this guy is implementing is detect and destroy. So first let's figure out where these helpers come from. So these are DRM atomic state helper. Okay. Which should get us all of these functions. Then we have this other probe single connector thing, which is DRM probe helper. Okay. And now we just have to implement connect and destroy. Okay. Which means that we have to take these function pointers. What was it? It was detect. So we take this and destroy. Okay. And as far as I understand at this point, I don't really see why we would need to destroy anything. It might be interesting to look at their implementation of destroy. So they do have some stuff in here. So it looks like we should probably do that stuff. Probably. And then here, we will also have spherocon detect. And I think for now, we are now going to have to start trying to find our, like somehow we must be able to get into our driver specific private data and use that to find a memory mapped section that we can query for our connector status, right? So what do they do in their version of this? They have DRM connector to vert GPU output, which just says that the connector, the vert GPU output is like a parent of the connector. Okay. I see. Which means that they must, when they allocate this thing, this must come from a connector pointer. A connector pointer. Oh, they have init with connector funcs and GPU con helper funcs. Okay. So this connector doesn't really exist yet, right? Oh, he comes from output connector. Fuck. Right. Okay. So when he, how did he make this thing again? I feel like we got there somewhere. So vgdev outputs. I guess maybe these are just default initialized, maybe? Maybe. Outputs. On VQ, he sets them, but presumably this only happens after he calls getDisplay. So yeah, I think on initialization, they are kind of just default initialized. And then they query them later. So we don't have to do it that way though. We can query stuff right off rip if we wanted to. But if I remember correctly, the kind of like initialization pattern here is that this stuff is supposed to get lazily initialized when you call get resources. Or something like that. Okay, fuck it. We're just going to make a connector. We're going to say that our GPU has one connector. So right now we also have no driver private data, which we're going to have to create now. So we're going to have like a struct spheroderv. And he is going to have, I don't know what like the ownership, the like order here is. I think it's that the PCI dev owns We set private data on the PCI device or something. No, because we don't really care about the PCI device. I kind of want to say that we have like this. We're going to have like a memory mapped region in here. So can we look at like LEDs, Pharaoh, to see what we did there? Here we had like a registers array that we mapped in. Okay, and then on the vert.io side, how do they create like private data for the structure? They have vert.io device private. How do they attach it to DRM? Hold on. I guess maybe we don't have to. We might not have to. Oh, here. They do it this way. They attach it to dev private. So we could do something that's like when we initialize, we're going to be like DRM dev private is equal to Sphero dev, right? Theoretically. If we need it. I don't think we're going to need this necessarily, but it's good to have it like there to reference. We are going to have to like create our device handle though. So we're going to have to be like, how do we do it in LEDs, Pharaoh? I assume it was just like a KZalloc or something. Yeah. So we allocated our device like this. I guess calling it priv does make sense. That kind of, it is our private data. So I'm okay calling it that. And then we assign things that we care about. So if we're claiming that we want a connector in here, because then if we have this, we can in here, and then we also want like our regs map, memory map. I think it's probably just like this. Probably just like this. So then we can do here, we can say that like struct Sphero priv star priv is equal to container of, and we are looking for type and member and pointer. So we get pointer is me, connector, and we are looking for struct Sphero priv who has a member called connector inside. Now we can do something that says like priv regs 0. We can just return. We can check this thing. So what are our possible connector statuses? We have connector status connected, disconnected, unknown. So we can just say if this is equal to 0, i.e. like this is going to be like memory mapped PCI device memory directly. So this will give us like the right now state. So this 0 will return connector status disconnected. And if it's 1, we'll return connected. Okay. So far, so good. So far, so good. So now we have these like GPU connector functions, and we just have to register them somehow. So first of all, we have to memory map this register section, which we had kind of already in here like this. And so we'll just say that priv regs is equal to this. Okay, and then also we now have a problem where error DRM, like, also is going to have to free our private data structure. No, because we have it devm alloced. Devm is so fucking sick. Devm is just like when the it'll free itself. It'll free itself. We don't have to worry about it. Fuck yeah. Okay. So what do I want to do here? We need to feed our connector, right? That's really all we've been trying to do for like fucking like 40 minutes or something. So we were referencing vert.io GPU derv. In his initialization, he gets into mode set init, and he gets into output init. And he calls this connector init here. So we're just going to do the same fucking thing. Now, I don't know what DRM connector helper add is, but I think that we can probably assume... I actually don't know what this does. So maybe we won't do this yet. Maybe we'll only do this. So let's go back to our driver. And once our driver is registered, I think we go do it before it's registered, we do this stuff. I think. We can look. So they call mode set init before register. Right, okay, so we're chilling here. Sorry, so we're looking for Sphero driver. So here our things are named differently. So we have the DRM dev, we have priv connector as a pointer. We have Sphero GPU connector funcs. And we have a virtual connector. So what I'm hoping to see here is that we are eventually going to get into this connection detect function. That's what I'm hoping to see. So we're going to say like detecting connection. And in order to implement this, we are going to have to go onto the PCI virtual machine side and have it return 1 or 0 in this section. But for now, let's just kind of run what we have now and see what it does. Let's see what it does. Ooh, dude, my brain is like struggling to keep up. It's like there's so much stuff and you need to map it all. You have to have like such like I don't know if you guys map it this way, but I kind of like feel like it's the same skill as like 2D game, right? You're like, I have this thing over here and this thing over here, and I'm trying to go from this room to that room. It feels like very, very similar. Very similar. And I'm just like, there's too many rooms, man. So he's mad because we're already running. So we run it again. Okay. And let's get root and test tab. Count connectors 1. Let's fucking go, baby. And now we want to check if the connector is connected. So let's go into our PCI device implementation here. And we're gonna have to make it so our thing is no longer like an LED system, right? Our thing is now just going to say connected. And I guess we'll just say, we said it was on 0. So if we are at 0, we're gonna say, if we try to write that thing, I guess we'll just reject the write. We can't write this thing. So I don't really know how to do that. So fix me reject write. Okay. And then I don't know if there is a way for us to reject a write, to be honest. I don't know if that's possible. It might be. This write LED values thing is no longer reasonable. We are no longer an LED device. And then here, if we read that thing, we are just going to return true here. Sorry. We return true. Or I guess we return 1. I guess maybe for, just for completeness, can we just return like, you know, like, cafe food and try to use that as a sentinel value to make sure that we on the other side are seeing the same thing. So in our device driver, we should see, we should basically just see that this says cafe food. So if this equals cafe food, we can say that this is connected. And here we'll even print yum yum food time. And hopefully, if everything is connected correctly, we should see this happen. We should see this happen. How the fuck did I end up here? Sphero. Okay. Yeah, that seems reasonable. Reasonable. So I guess we're kind of just kind of saying like in the driver side, we'll just kind of hard code it as connected. I don't really care about that as much. I'm more interested in the driver side. And then everything else I think should just work. Maybe. Let's rebuild QEMU. So I think it's QEMU system x86 64 or something. He's mad because this is also unused, so it's fine by me. Okay, so now our new QEMU should return cafe food when we read that thing. And hopefully we just see that log printed somewhere. I guess we could also log on the QEMU side, but I think it's fine. It's fine. We don't need to. So let's also build our kernel again. Let's build our kernel again. Give him a sec to think. Yeah, I'm a second-year computer science student. I'm struggling with problem solving. I find it hard to start projects from scratch without relying on tutorials or looking things up a lot. I'm trying to get better at tackling problems on my own. I really appreciate any advice or tips. I think it's like a practice thing. I think it's a practice thing. Like, I think that if you're like, I'm trying to get better at tackling problems on my own, I think like looking things up, I think is fine, depending on what you mean by looking things up, right? Everybody has to look things up because nobody starts with knowledge. You have to get the knowledge somehow. But eventually, if you do it enough, it should internalize, right? I think tutorials, I try to stay, like sometimes tutorials are necessary, but I try not to rely on them too much. I try to think of like when you're studying for tests, right? You can like have cheat sheets or like answer keys, right? And if you just read the answer keys, then you're fucked, right? You'll never internalize the knowledge. But if you use the answer keys to check if your understanding is correct, then you're in a much better spot, right? And so I try to think of like tutorials as like kind of that type of thing where like you might use it for like an overview, but then you should go try to tackle the problem yourself and then come back and see if you got the same answer. Or use it as like when you get stuck. But I think just like, you know, just building stuff. I mean, I'm very biased because my brain is my brain. And so I only know how to think the way I think. But from my experience, just doing stuff means that eventually you have to figure it out. You don't have a choice. So just do stuff. Okay. So I do not see anything here. But we might still see the cafe food up here somewhere. So first of all, can we change our app to check for the connected field? That might be interesting. But then also I want to, before we do that, maybe we look for detecting connection up here because we expect that to have been called. So this is vert.io GPU. This is us. Successfully registered with DRM. I see yo, what's up? But I do not see anywhere us trying to detect a connection. So we might not be understanding this, or we might have to go a little bit further in our user space test app case, right? So in here, we do call get first connected connector, and in each of these, we do call get connector. However, I do remember something about current is the one that doesn't allow it to change. So here, can we std debug print iterating looking at connector. Okay, and maybe even here we print out, maybe we say connector D ID has mode this. And then we can say connector ID and connector connection. Let's just kind of see how that plays out. So here we had zig build and this, and then we also have to set up our thing's not open, so we need to run. And then we need to set up networking. EMP03, okay. And then we go back into our test app and run zig build. And count connectors is 1, but we don't ever see our log there, right? Connector this has mode. So like, what am I missing here? We see driver name printed, we see this printed, but then like this just kind of, nothing really happens. Looking for connectors. It almost like it just fucking ends. Like, what am I missing? Oh, he just never finishes. So he's blocked somewhere. Oh, wait, okay, here we go. Bug null pointer dereference. Aha. Okay, so test app. Okay. So this is coming from probe single connector modes. DRM helper probe detect. And this is coming from get connector. And then probably we're like kind of like bugged the fuck out because it bugged with a mutex locked or something. And so here we're probably fucked. So this is like an interesting place to look for. DRM helper probe detect. DRM helper probe detect. Okay. So like, what does this thing do? What does he do? He calls connector funct detect or detect CTX, depending on what's implemented. So we implemented detect. Okay. Okay, so this does try to call our function, but he is null pointer dereferencing. So he's looking at 8 bytes into a null pointer, essentially, is what we're probably seeing here. Which is kind of surprising. Okay, so if our private data was not set up right, we would kind of see an issue here. I mean, this could be relevant in some way. Could be. DRM dev is a stable pointer to something, right? Connector is a stable pointer because priv was allocated. So there should be no like references to old stack memory hanging out here. I don't think. I guess we just have to start logging down the path, huh? We just have to start logging. So file priv is from DRM file. So he's doing like DRM connector lookup. Okay, so we're in get connector, helper probe single connector modes, right? That's where we want to find. So single connector probe single connector modes. I think we found this already. Right, so we have this implemented on our version of this. Right. And so in here, something bad is happening. And I guess we just have to figure out what that is. We just have to figure that out. So there's a lot of stuff that could happen here. Okay. And then I also suspect that this now feels like it's important, right? I know we said we weren't sure, but now that I see that like in here, he's doing a bunch of work, we can presume that this DRM connector thing is doing some interesting pieces of like interesting assignments. So maybe we go back into this guy, our reference driver, and we go back and try to find where he does that thing, and we can look at what actually happens there. So it was this helper add. So he has these functs such as get modes, right? So what does this do? He calls helper private functs. He sets those to things like get modes, okay? So we're going to keep that in our heads. That this gets assigned to helper private, right? Now, when we go back to whatever function we were fucking failing in, which was probe connector single. Probe single connector, sorry. We're looking for him to look at... Oh, fuck. We're looking for him to call fill modes. Right? I think that's what we're looking for. Oh, no. We're looking for infill modes for him to call something priv with... I already forgot. So what file is this? This is drm probe helper. Can't forget that. And we are looking for him to call something that looks like get modes. Connector func get modes. Yes. Okay. So this is kind of just unconditionally fucking doing that, right? We don't see any null checks here, which would indicate the crash, right? And we know that these are supposed to be done here, so I think that makes sense. So for now, we will call this function. This is important to us. So we're going to copy paste their helper function handles into our version. Boom, and we'll call this Sphero. Boom. Okay, and then we just have to implement these functions. So we have get modes and mode valid. Boom. Okay, so this is Sphero GPU con get modes. And Sphero GPU mode valid. Boom. And I don't really know what these do yet, right? But we will see. So these need to be static for him to stop bitching and whining this guy. And then I don't know why he thinks that this is undeclared. This needs con mode valid, I guess. Okay, and then we need to call this helper function with Sphero GPU and priv connector. Okay. Now this thing needs to be defined somewhere. So we use the auto-resolved header. Okay. Sphero. Did I spell? You said I wrote AERO. You tricked me. And then we have to figure out what this thing is fucking supposed to do, which we have no idea, right? So this function should fill in all modes currently valid for the sync in the DRM connector probe modes list. It should also update the EDID property by calling DRM connector update EDID property. The usual way to implement this is to catch the EDID blah. Okay, so we're supposed to do some stuff. But what if we just didn't do some stuff? Oh, Sphere IO. Nice, I get it. Nice, good one. Okay, so we're just gonna not do that. And I guess we will just kind of unconditionally whoa, what is this supposed to do? I don't really understand what that mode status is. Callback to validate a mode for a connector, irrespective of the specific display configuration. This callback is used by the probe helpers to filter out the mode list, which is usually derived from the EDID, blah. This function is optional. Oh, you don't have to tell me twice. You do not have to tell me twice. Get that shit out of here. Okay. Let's see what happens. So hopefully that fixes the crash. And I guess, theoretically, if we were to actually populate the modes, we would have to ask the PCI device what it thinks the monitor has, or maybe there's some sort of like generic like monitor thing, right? But like, yeah, it must be, right? I plug my monitor into my graphics card. I guess my graphics card is the one who is asking the monitor, hey, what resolutions do you have? But maybe EDID is something to do with that. I know I've seen EDID as like a monitor thing around before. I don't really know what it means, right? But maybe there's something there, right? But like I guess there you have to ask your GPU somehow to give you information about the monitor. It's just whether or not that's usually propagated in some sort of like known generic interface, right? But let's he's mad because he's already running, so we run him again. We run into our test app. I guess we don't have to re-upload him. Okay, so it looks like we're fucked again. We did see looking for connectors, detecting connection. We got yum yum food time. Okay, so that's really good. That means that somebody probed the connector, and we found the connection from the other side. Right, so that's pretty cool. But DRM helper update and validate is like getting angry, presumably because he said that we have to do some stuff that we didn't do. Right, that would be my assumption. That would be my assumption, is that this get modes actually is supposed to do some work. So let's look at DRM mode validate driver. Validate basic, probably, and then he is full on just crashing, which means that this guy's kind of just like hard dereferencing mode. So this is coming from probe single connector something, which weirdly does not look like it's like part of this. So let's go to DRM helper probe single connector modes. And they're saying there's some sort of validation that happens in here after we try to populate modes, which was probably here. Probably prune invalid. No. Probe single connector modes. Is this where I am? Probe single connector modes. It is. Sup. So I would heavily suspect that someone is trying to use those modes directly. I could be in get modes too. So he calls get modes. Then, oh, this returns count. And it could be in here, because we are in this case where we return 0, kind of just like without thinking. And it could be in here, but it's still not really clear. DRM mode validate driver. Kind of annoyed that like going upwards from here, like isn't really going where I want it to. Oh, here we go. DRM helper update and validate. Okay. Update and validate, who calls validate driver with a mode, who comes from mode. Right, so we're iterating over connector modes from head. List for each entry connector modes. I see. So this is probably just not initialized by us. Right, and then this is just accessing invalid memory. Right. If list empty connector modes, and the connector type is this. So we must be in here? I don't really understand how we end up in either of these cases. Unless we're like getting command line modes somehow. Which I don't think we should be. Our kernel command line does not do any modes. But I mean, we must be getting count not equals 0 somehow. We must be. So we have here if count equals 0 and we have a connected status, which we do. Then he adds modes, no EDID. I see. So he automatically adds a mode here. And then validating that mode, he's got a fucking problem. Presumably. So that's actually kind of surprising. Because that kind of indicates that the mode field is not like a null pointer, because they kind of added something. Which is kind of surprising. I guess. If only we had breakpoints. That would make my life so much easier. Okay. So maybe we look at the requirements of this function again. This function should fill in all modes currently valid for the sync into the DRM connector probe modes list. It should also update the EDID property by calling update EDID property. Okay. But what if we don't do that? The note the caller function will automatically add standard VESA DMT modes up to 1024 by 768 if the get modes helper operation returns no mode and the connector status is connected. There is no need to call this manually in that case. Virtual drivers that just want to implement some standard VESA mode with a given resolution can call DRM add modes EDID and mark the preferred one using set preferred mode. This function is only called after detect hooked has indicated. Okay. To avoid races with the current connector state updates, the helper libraries always call this with this thing set held. Okay, which means is it safe to inspect this? Great. Okay. So it sounds kind of like we should see what the vert.io version of this does. It sounds kind of like we should call the no EDID version of it. Kind of like just hand wavy. That's kind of how it feels to me. So let's see what they do. Mode set init. Output init. Connector helpers. Okay. So we could just kind of do this. We could try just doing this. I guess we shouldn't copy, but we should copy paste and then do it on our side. We could try that. So what is our return? Int. And then can we do like 1024, 768 and set that as their default? That's kind of what I feel like I want to do. That's how I feel like I want it. And then we return count. Maybe. Maybe. Evening Svei. Hello. What's up? Welcome back. It's so fucking stupid. All right. Let's see what happens. Hopefully it works. What does this do? So we should find out what an EDID is eventually. Because it is kind of silly to just kind of like run this shit kind of blind. But I don't want to right this second because it is almost 4:30 and I wanna wrap her up. So we are still no good here. Still no good. And we are still just null dereferencing in update and validate. Which is a little annoying. Because that means I just don't understand something. Which is fair because we're kind of lost as fuck. It would be really nice to get GDB up and running. So I think it's silly. To try to hunt this with bad tooling. I think it's stupid, right? Because in reality, we should just be able to like look at the answer and like I would rather invest my time into doing that. So I think we call it here. I think we've made some reasonably good progress, right? We have a GPU driver that has been instantiated and talks through PCI. He talks to the PCI dummy device to ask if we have something connected. And as we try to use that connector in some way, we're segfaulting, and I think that it just makes sense to open GDB and look, but we haven't have GDB up and running, so I will look at that tonight. We'll run back at it tomorrow. Thank you for watching, guys. I hope this is interesting for you. If you like what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. It is 4:30 now, so if you're watching live, anywhere between 4 hours ago and now is when we usually stream. If you're new, there is a YouTube link in the description where you can check out all of our previous projects. So there's a bunch of stuff in there if you want to check it out. QR code decoder, like map. We made a map of Vancouver. We did like a video editor, operating system. There's stuff in there that's cool if you want to check it out. There's a GitHub link in the description where code for this will eventually end up. We are kind of working this like GPU testing env, so it'll probably end up in here eventually. What else? If you're watching on YouTube, there should be a Twitch link in the YouTube description. Swing by, say hi if you want to. And I think that's all. Like, subscribe, Twitch Prime. There's a Discord link in the description if you want to like hang out while we're not live. And I think that is all. I guess if you want to see like happy hour VODs, we sometimes do stuff that's like in the 2 to 4 section. We kind of work on like what you're seeing right now. But sometimes we kind of do like a little bit more laid back, like cleanup, reading, like unit testing, stuff like that. Kind of like less like hyper progress, more like try to get shit done, like shit that needs to get done to support the hyper progress. So if you want to check that out, those are archived on Patreon and YouTube members, or live at 12:30 to 2 most days. So I think that's it. I think that's all the plugging that we should do. Goodbye, YouTube, and Twitch. Let's find someone to raid.